Hello everyone. So this is a question from JEE Mains 2026, 6th April Shift 2. X is the product which is obtained by hydrolysis of prop-1-yne in the presence of mercuric sulfate under dilute acidic medium at 333 Kelvin. Okay. Y is the product which is obtained by reaction of ethane nitrile with methyl magnesium bromide in dry ether followed by hydrolysis. IUPAC name of product obtained from X and Y in the presence of barium hydroxide followed by heating is. Okay. So we have to find out the structures of X and Y. And the chapters involved is hydrocarbons, GOC, aldehydes, ketones, and carboxylic acids. Okay. So to get X, we are doing hydrolysis of prop-1-yne in the presence of mercuric sulfate, that is HgSO4, and dilute acidic medium at 333 Kelvin. Okay, that is, with respect to reaction, I can write CH3 C triple bond CH. So this is my prop-1-yne plus H2O, and let's say the acid I have taken is H2SO4. I have also HgSO4 and 333 Kelvin. Okay, this reaction is basically hydration of alkynes. Okay, under these conditions, the H2O adds to the triple bond according to Markov-Nikov's rule to first form an enol which tautomerizes to the corresponding carbonyl compound. Okay, important. So what happens is H2O adds to triple bond according to Markov-Nikov's rule to form enol which undergoes tautomerization to form the corresponding carbonyl compound. Okay, so that is I can write this H2O as HOH. OH is the negative part, H is the positive part. So according to Markovnikov's rule, we know that negative part of the reagent, that is OH, goes to the carbon with less number of hydrogen. So OH will come to this carbon, and the positive part of the reagent will go to the carbon with more number of hydrogen. So it will come here. Okay. So showing arrows, OH will come to this carbon, H will come to this carbon. So we will get this guy, CH3C OH, and the triple bond will be converted into a double bond, CH and H. Okay, so this is our enol. Okay, so this is known as enol because you can see, look at this carbon. It has both double bond, that's why ene, and also an alcohol group attached to it plus ol, which is known as enol. Okay, and enols can show tautomerism, and to be specific, keto-enol tautomerism, very important. Enols can show keto-enol tautomerism. Okay, in keto-enol tautomerism, hydrogen migrates from one polyvalent atom, that is having more than one valency, to the third polyvalent atom within the same molecule. Okay, so that is, if I draw the enol again, CH3C OH double bond CH. So let's say this OH is my first polyvalent atom. Okay, this is my second carbon, this is my third carbon, which is my third polyvalent atom. So what happens is hydrogen migrates from one polyvalent atom to the third polyvalent atom within the same molecule. So this hydrogen will be transferred to this carbon, and this pi bond will now become a pi bond. So this original pi bond was between C and C. Now it will become a pi bond between C and O. Okay, so therefore, after it undergoes tautomerism, we will get CH3 C double bond O CH3. That is, this hydrogen is transferred to this carbon. These pi electrons are transferred to between C and O. So we get this guy. Okay. And you can look at these arrows. This shows that there is dynamic equilibrium between these two as they are tautomers of each other. But in this case, the keto form, that is this guy, is more stable. Okay. So this is the keto form. This is the enol form. Okay. And this is our acetone. And one more thing is the keto form is more stable. Okay, important. So keto form is more stable because of the greater strength of the new carbon oxygen pi bond. This is the new carbon oxygen pi bond that we formed. So this has more strength compared to the original carbon carbon pi bond in enol. Remember, this was the bond initially. So the strength of this bond is 254 kilojoules per mole, and the strength of the new bond that we formed, this one, is 364 kilojoules per mole. So that's why the keto form is more stable. Okay. So therefore, ultimately, this guy is our X. X is nothing but acetone. Okay. Cool. To get Y, we are reacting ethane nitrile with methyl magnesium bromide in dry ether. That is, with respect to reaction, that is, I have CH3C triple bond N plus CH3 MgBr. Okay, Mg, it's a metal, so therefore I will give partial positive charge. This carbon will have partial negative charge. N will have partial negative charge, and carbon will have partial positive charge. N being more electronegative will take these electron pairs, and this CH3 will go and attack our positively charged carbon. Okay, and this happens in the presence of dry ether as we are using a Grignard reagent. Okay, so we will get CH3C, CH3, double bond N, Mg, Br. So this is our intermediate adduct. Then we are doing hydrolysis, that is H3O plus. So then we will ultimately get CH3, C triple bond O, CH3 plus NH3 plus we also get MgOH, So these are the side products. Okay. So therefore, this guy is our X, which is acetone. Okay. So we have X and Y, that is two molecules of acetone. And acetone is a ketone with alpha hydrogen. So you can see CH3C double bond O CH3. So these are my alpha carbons. So, and both the alpha carbon has alpha hydrogen. Okay. So two molecules of acetone, which is a ketone with alpha hydrogen, condense in the presence of a dilute alkali. So it is given to us that we are reacting them in the presence of a dilute alkali, which is barium hydroxide. So these guys will condense in the presence of a dilute alkali to form aldols, and the reaction is called aldol condensation. That is, with respect to reaction, one molecule of acetone, I can write it like this: CH3 C double bond O CH3. The other molecule, I will write it like this. I will separate one alpha hydrogen, HCH2 C double bond O CH3. Okay. Now this oxygen is partially negative charge. This carbonyl carbon is partial positive charge. Alpha hydrogens can be lost. That's why partial positive charge. CH2 gets partial negative charge. Okay. So oxygen, it can take away these electron pairs, and this hydrogen will go and be a part of this oxygen, and the rest of the molecule will come and attack my this carbonyl carbon. Okay, in the presence of obviously BaOH twice. So I'll be getting CH3COH, CH3, and this whole molecule will form a new bond with this carbon. So CH2 C double bond O CH3. Okay, then we are heating it. So the aldol which is formed, that is this guy, undergo dehydration, leading to formation of alpha beta unsaturated aldehyde or ketone. Very important. Okay, whenever we heat the aldol, it undergoes dehydration to form alpha beta unsaturated aldehyde or ketone. Okay, so because of the action of heat, OH from here, and I will separate one H from here, that is CH and H. So OH from here and H from here goes out, and there is a double bond between this carbon. So the product that we get is CH3 C CH3 double bond CH C double bond O CH3. Okay, so you can see this is my alpha carbon, this is my beta carbon, and there is a double bond between them. That's why they are known as alpha beta unsaturated. So in our case, it is a ketone, and obviously a molecule of water. Okay, and the IUPAC name of this guy will be, first let's decide the parent chain. So this is our parent chain. You can also take this as your parent chain. Okay, so and the functional group will get more priority, so the numbering will start from left. Therefore 1 2 3 4 5. Okay, and in the fourth position we have our substituent methyl, so therefore it will be 4 methyl. There are total 5 carbons, so pent. In the third position we have the double bond 3 ene. Then in the second position we have ketone one. So remove this e. Okay, so therefore the final name will be 4 methyl pent 3n 2 one. This is the IUPAC name of the product formed from X and Y in the presence of barium hydroxide followed by heating. Okay, so this is the final answer. Thank you.